Okay, let's start today differentiation session. So last 2 weeks I did how to differentiate function using first principles. Then I have done special function derivatives of special functions, and thereafter composite function derivative. Okay, when two functions are added or subtracted or multiplied or divided, we can differentiate using rules on differentiation. And also we done the things about function of a function type differentiation, function of a function type differentiation, and also exponential functions and parametric functions. So we have to practice more questions on that. And thereafter we can go further to differential equations today. Okay. Now see this one first. Now when you have two functions product, y equal fx times gx. So here we have product rule. Here. dy by dx equal fx times g dash x plus gx times f dash x. That is equal product rule. Fx times gx, then fx times g dash x plus gx times f dash x. We have product rule here. Now further, if you have product of three functions like fx, gx, hx, here we have product of three functions. Then you say here dy by dx, here f dash x times the other two product gx, hx plus fx times g dash x, hx plus fx gx, h dash x. It goes like that. If you have three function product, you follow same technique. Then here f dash x times the other two, g dash x times the other two, h dash x times the other two. Okay. Then likewise y equal fx, gx, hx and pi x. Here we have four functions. Here. Then you write here dy by dx. Here take f dash x and multiply the other three gx, hx, pi x plus fx times here g dash x, hx, pi x plus fx, gx, h dash x, pi x plus fx, gx, hx, pi dash x. That's how we differentiate. When you have four function product, you can follow same technique. That's how we apply product rule. Okay, write down, put that note. Here product rule. Extended product rule. Here extended product rule. Let's practice it. Take that worksheet. Take that worksheet. Page number 3. Page number 3. Question number 15 to 19. Question number 15 to 19. Let's do soon. Let's do soon. Page number 3. Exercise 10. Exercise 10. Question number 15 to 20. 15 to 20. Okay, start it. Page number 3, exercise 10, question number 15 to 20. I need only first step. I need only first step. Y equal x squared e to the power x tan 2x. If you are in doubt, do with me. Dy by dx, x squared derivative 2x, ex tan x, plus x squared times ex derivative ex tan x, plus x squared ex tan derivative sec quad. Sec quad. Tree function product. X squared derivative 2x, write the other two. Ex derivative ex, write the other two. Tan x derivative sec x, write the other two. In question number 16, y equal 2x plus 5 sin x tan x dy by dx 2x plus 5 derivative 2 sin x into tan x plus 2x plus 5 sin derivative cos into tan x 2x plus 5 into sin x into tan derivative sec quad x. Do alone. Here first on tan 2x na, tan 2x, here tan 2x sec qua 2x times 2 function of a function type. Continue. Question number 17, y equal x square plus 1 sin x tan inverse x, sin x tan inverse x, then dy by dx, here derivative 2x sin x tan inverse x square plus 1 sin derivative cos plus x square plus 1 sin x tan inverse 1 over 1 plus x squared, 1 over 1 plus x squared. Then y equal x cube e to the power 2x sin x, then dy by dx 3x square e to the power 2x sin x cube e to the power 2x times 2 times sin x cube e to the power 2x sin derivative cos. Then y equal x square e to the power 2x sin 2x cos 4x. So here it has 4 function products, no? 4 function products. You follow previous technique, dy by dx, here derivative 2x e to the power 2x sin 2x cos 4x plus x square e to the power 2x times 2 sin 2x cos 4x plus e to the power 2x, before that x square e to the power 2x sin derivative cos 2 into cos 4x, finally x square e to the power 2x sin 2x cos 4x means minus sin 4x times 4. Continue. Okay. Then last one, y equal x squared e to the power minus x squared sin x tan x. Sin x tan x. So there also we have 4 function products. Then dy by dx, x squared derivative 2x e to the power minus x squared sin x tan x plus x squared e to the power minus x squared derivative e to the power minus x squared times minus 2x, put bracket properly, sin x tan x plus x squared e to the power minus x squared sin derivative cos plus x squared e to the power minus x squared sin x tan derivative sec squared x. Okay. Okay. Then again I told you to do page number 4 last question set. Derivatives of for given subject, different subject. So I'll discuss that one as well. We know how to differentiate function with respect to x. Then if we need to differentiate y with respect to x, we denote that one by dy by dx. No? dy by dx. If we need to differentiate t with respect to x, you have denote that one dy by dt. No? Y with respect to t. Okay. Now here we need to differentiate sin cube with respect to sin x. That means d sin cube divided by dx needed. D sin cube x divided by dx needed. Okay. Now here the way y equal, take y equal sin cube x first, then t equal sin x, t equals sin x. Here you need dy by dt, you need this one. Now I can write here in terms of t, sin x means t, no? Then t cube. Then here dy by dt equal 3t squared. Finally replace t. T means x, no? 3 sin squared x. Likewise we can easily do. Check your answers. Huh? If you haven't done, do with me. Here question number 1. Question number 2. Take y equals sin inverse 2x over 1 minus x squared. Here you have differentiate with respect to tan inverse x. Then here you need dy by dt. Then here x equal tan t, no? X equal tan t. Put it here. Y equals sin inverse 2 tan t over 1 minus tan square t. Then sine inverse, here tan to, not sine inverse, no? Tan inverse. Tan inverse. Here tan 2t. Then tan inverse tan 2t, we get 2t. Then dy by dt equal 2t derivative 2 times 1. 2 times 1. Okay. Here we can easily substitute that variable t, no? We can easily substitute that variable t, then we can easily differentiate that. By substituting, we can differentiate that. Do with me. Question number 3. Y equal tan to the power 5x. Let t equal tan x. Then here t to the power 5. dy by dt 5t to the power 4, t mean tan. Then y equal cos to the power 4x. With respect cos x, t equal cos x. Then y equal t to the power 4 dy by dt 4t cube, t mean cos cube x. Then y equal ln x to the power 6 need to differentiate by x cube. Then put it here. Then y equal ln x cube mean t, no? Then write t square. Then 2 ln t, no? Then differentiate. dy by dt 2 times 1 over t. 2 times 1 over t. Okay. Then replace now t. Replace now t. Then here we know t value, that is x cube. 2 of x cube. Continue. Check your answers. Then y equal x to the power 6, x cube plus 1, need differentiate x cube. Then here t square, t 1, dy by dt 2t plus 1, dy by dt 2t plus 1. Then replace t mean x cube. Then y equal x squared over x to the power 6 plus x to the power 4. Here take t equal x square. Then here t cube, t square, you can cancel 1t. Then 1 over t square plus t. Then dy by dt, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Okay. Then finally, you substitute that t given t value. Substitute given t value. T mean x square, no? 2x square plus 1 over x to the power 4 plus x square to the power 2. That's how we differentiate with respect to another subject. Using substitution, you can do that. Right? Let's move a little further. We have to practice few questions on differentiation, then we can go to application of derivatives. Okay, take your worksheet again. Page number 3, exercise 8. Page number 3, exercise 8. Page number 3, exercise 8. Okay, I'll just revise you this. See this one? Y equals sine inverse x. Then derivative dy by dx 1 over 1 minus x square root. Then y equal sine inverse 2x. You say dy by dx 1 over 1 minus, instead of x you put 2x, times 2x derivative 2. Y equals sine inverse fx. Then you say dy by dx 1 over 1 minus fx square root times fx derivative f dash x. F dash x. Y equals sine inverse 2x minus 1 root. Then dy by dx. Here we have sine inverse function. You differentiate is sine inverse 1 over 1 minus x square root, whole thing root. Here x square means 2x minus 1 square root, its square, into inside function square root. Square root derivative 1 over 2, 2x minus 1 root, no? Then into inside function 2x minus 1 derivative 2. Derivative 2. Okay. Likewise, we can proceed this. Then here sine inverse x, no? Likewise, we have different inverse functions. Then y equal cos inverse x. Then here we say dy by dx minus 1 over 1 minus x square root. Minus 1 over 1 minus x square root. No? Likewise, y equal tan inverse x. Then dy by dx, we say 1 over 1 plus x squared. 1 over 1 plus x squared. Okay. But here with inverse function, it represents like function of a function type. Function of function type. Okay. Here first, note this. So we have done this before, but anyway, just note it. And complete that question number 8, exercise 8. Okay, start it now. I'll give you a little time to start. Continue. Y equals sin inverse 2x, we did that. Y equal cos inverse x square dy by dx minus 1 over 1 minus x square to the power 2 root into 2x. Y equal tan inverse 2x square plus 3, then dy by dx 1 over 1 plus 2x square plus 3 to the power 2 inside function 2 times x square derivative 2x. Then y equal sin inverse 1 minus x square, then dy by dx 1 over 1 minus x square to the power 2 root times minus 2x. Cos inverse 3x dy by dx minus 1 over 1 minus 3x square root times 3. Do alone. You do and check answers. Check signs and brackets and pattern. Continue. Do alone. Y equal tan inverse half x. Tan inverse half x, then dy by dx 1 over 1 plus 1 over 2x square into half. Cos inverse x cube minus 1 dy by dx minus 1 over 1 minus x cube minus 1 square root. 3x squared. Y equals sin inverse cos x dy by dx 1 over 1 minus cos square x root minus sin x. Sin inverse x by a, here a constant, dy by dx 1 over 1 minus x by a square root x by a derivative 1 over a. Continue. Okay. Then y equal tan inverse ax plus b over ac minus b square root. Then you identify here, usually x variable, no? Then others are constants. Then here tan inverse derivative dy by dx 1 over 1 plus ax plus b ac minus b square root to the power 2 times derivative of this one. Clearly see this, huh? Here ac minus b square root constant, a constant, b constant, only x variable. So when you differentiate in this, here b gets 0 because it has completely separated, no? But here AC minus B square root with A and X, here this part. Therefore, X derivative 1, you have to write these things together. A over AC minus B square root, X derivative 1, like that. Here AC minus B square root A times X. Then Y equal cos inverse 2x minus 1 over 3, then dy by dx, cos inverse derivative minus 1 over 1 minus 2x minus 1 over 3 square root times here derivative of this. Here we have constant 2 over 3x and the other part separately, completely separated. No? Then you write 2/3 times 1. Here 2/3 times x derivative 1. Then minus 1/3 derivative 0. Minus 1/3 derivative 0. Then 2/3 x, right that way. Here 2x over 3 minus 1/3. Likewise, you can write here. Okay. Don't get here division formula, division algorithm, okay, but when you differentiate in this part, that gets 0. This constant. Okay. Then last one, check your answers. Y equal tan inverse 2x by 3. Then dy by dx, tan inverse derivative 1 over 1 plus 2x by 3 squared into 2x by 3 derivative 2 by 3. 2 by 3. Okay. Now let's do another one only. Exercise 11. Page number 3, exercise 11. You have 23 questions. I need first step only. I need only differentiation step only. Take time. Okay, check your answers. Check your answers. Y equal e to the power x over sin x. Now it is a division. Apply quotient rule. Dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Y equal x square over x plus 1, then dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Then y equal x over x minus 2x minus 3. Then dy by dx, denominator square, denominator times derivative of numerator 1 minus numerator times derivative of denominator. Here we have product, no? Then x minus 2 times derivative of x minus 3 1 plus x minus 3 times derivative of x minus 2 1. So while doing differentiation, we have to apply rules again. That can be function of function type, again composite function type, that can be there. Then y equal 1 minus x square 1 plus x square root. Then dy by dx. Here for square root part, 1 over 2 square root 1 minus x square 1 plus x square. Into here division, no? Denominator square, denominator times derivative of numerator, numerator times derivative of denominator, derivative of denominator. Check your answers. Then y equal x over ln x dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Ex over x minus 1 dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Then y equal x minus 1 x plus 1 dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. E to the power x over tan x, again division, then dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Okay. Continue. y equal x squared over x square plus 1, then dy by dx x square plus 1, x square plus 1 times 2x, x square times 2x, x square plus 1 over 6x, then dy by dx, denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. So here you can take 6 outside like constant time function as well. Then you can cancel 6 term. Then y equal x minus 1 root of x, then dy by dx, denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. Sin 2x over root x, then dy by dx, denominator is square, denominator times derivative of numerator cos 2x times 2 minus sin 2x times derivative of denominator 1 over 2 root x derivative. Okay, question number 13. Question number 13, check your answers. Question number 13, y equal ln x over ln x minus 1, then division, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Then 14, y equals sin x, sin inverse 1 minus x squared 1 plus x squared, dy by dx 1 over 1 minus x squared 1 plus x squared, whole thing root again division, denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. Two x over 1 minus x square 1 over 1 minus 2x over 1 minus x square whole thing root, denominator is square, denominator times derivative of numerator, numerator times derivative of denominator. Tan inverse 2x over 1 minus x squared, dy by dx 1 over 1 plus 2x over 1 minus x squared to the power 2, again division 1 minus x squared to the power 2, 1 minus x squared times 2x, 2x times minus 2x. Tan inverse derivative, then inside function division, derivative of division. That is question number 16. Here small correction. Denominator derivative only 6 only, not x there. Only 6. Question number 10. Here denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator, that is 6 only. Okay. Then y equal sine inverse 1 minus x 1 plus x root. Then dy by dx sine inverse derivative 1 over 1 minus 1 minus x 1 plus x root to the power 2, again square root. Square root derivative 1 over 2 root 1 minus x 1 plus x into, here denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. Check your answers. Then y equal tan inverse 1 plus x square root minus 1 over x. Then dy by dx 1 over 1 plus x square root minus 1 over x. Then here division, denominator is square, denominator times derivative of numerator. Here numerator derivative 2 square root 1 plus x square times 2x minus numerator derivative of denominator 1. Cos inverse 1 minus x squared 1 plus x squared. Minus 1 over 1 minus x square 1 plus x square to the power 2 root into division derivative, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Continue. Okay, then 20 x e to the power x 5x plus 3 denominator square, denominator times derivative of numerator, here product 1 times e to the power x, x times e to the power x derivative e to the power x minus numerator times derivative of denominator. X square plus x plus 1, x square minus x plus 1 root. Then dy by dx square root 1 over 2 square root 1 plus x squared plus x plus 1 x square minus x plus 1 into division. denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Identify proper combination. There can be different technique. If you have any different answers, just ask me. Then y equal 4x plus 5 x squared tan 2x. Then dy by dx x squared tan 2x, denominator square, denominator times derivative of numerator 4, numerator times derivative of denominator. Here we have product. Then 2x, x square derivative 2x into tan 2x plus x square times tan 2x derivative sec square 2x times 2. It is function of a function type again. Tan 2x derivative sec square 2x, 2x derivative 2. Do alone. Okay, then question number 23. 23. Y equal 2 times x times e to the power minus x, 2x minus 3 sine 3x. Here first get these 2 outside. It's right here. dy by dx. Here you can take constant time function. Take 2 outside. Put bracket. Then here division, no? Then denominator is square. Denominator is square. Denominator times derivative of numerator here. Open bracket. Then here product x times e to the power minus x derivative e to the power minus x into minus 1 plus x derivative 1 e to the power minus x minus numerator times derivative of denominator. Derivative of denominator here we have. Then denominator contain product. Then 2x minus 3 times sine 3x derivative cos 3x times 3 plus 2x minus 3 derivative 2 into sine 3x. Then y equal e to the power x square sine 2x x square ln x. X square ln x. Then dy by dx. Denominator is square. Denominator times derivative of numerator e to the power x square times sine derivative cos 2x times 2 plus e to the power x square derivative e to the power x square times 2x minus numerator times derivative of denominator. It has again product 2x ln x plus x square 1 over x. Check it. Then last one, x square minus x plus 1 root ln x square plus 1 root division ln x square plus 1 root to the power 2, denominator square, denominator times derivative of numerator, here square root, derivative of inside function, here 2x minus 1, minus numerator times derivative of denominator, ln derivative 1 over, then square root, then x square plus 1 derivative 2x. Now write down next topic, higher order derivatives of parametric functions. 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 Okay, just write. When differentiating a parametric function, 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 chain rule is used. Chain rule is used. Chain rule is used. Then for higher order derivatives, for higher order derivatives, for higher order derivatives, again must be considered chain rule. Again must be considered chain rule. Okay. Now check this. Here this is somewhat rare case, okay? Somewhat rare case. So last 2 years, last year it has checked, okay? But for last 10-15 years we haven't checked second derivative or third derivative of parametric functions. Okay, now see this simple, y equals sin x, sin t, this is sin theta, x equal cos theta. Then let's say you're going to find dy by dx, d squared y by dx squared, second derivative, d cube by dx cube, third derivative. You got to find this parametric function. You apply same technique, okay? Then y equals sin theta, then dy by d theta equal cos theta, x equal cos theta, then dy by d theta minus sin theta, Then by these two you apply chain rule. To obtain dy by dx, write dy by d theta times d theta by dx, no? We know this. We apply chain rule, no? Parametric function. So definitely for your A-level part A question, usually it contain parametric type function. Then you have to practice this type. Then dy by d theta, we know that is cos theta. D theta by dx, here dx by d theta, here dx by d theta, no? Then dx by d theta minus sin theta, no? Then need d theta over dx, that means reciprocal needed. 1 over minus sin theta, then the result will be minus cot theta. Do up to that. First do up to that. Here example. Here if y equals sin theta, x equals cos theta, then find here derivatives. check. Now check second derivative specialty. Check this and all. Now up to now we know dy by dx. Up to now we know dy by dx minus cot theta. No? Minus cot theta. Okay, let's write it. Dy by dx equal minus cot theta. See this one clearly. Minus cot theta. Now dy by dx in terms of theta, no? That is in terms of theta. Dy by dx in terms of theta. But you need second derivative with respect to x, no? That means we have to differentiate with respect to x, not theta. Okay, let's do this. Say d squared by dx squared. Then write here d minus cot theta divided by dx. You have to differentiate x again. You have to differentiate x again. Then chain rule mean here this contain theta, no? Then we can't differentiate with x now. Therefore you do this. Say you can take minus outside, d cot theta divided by, you can differentiate by theta and write d theta divided by dx. Then d theta we can see like cancelling process. Then we get d cot theta over dx. Similar expression we can obtain. That is we call chain rule. Chain rule. Then d cot theta over d theta means you have to differentiate cot theta with respect to theta. Then differentiate it. Minus cot derivative minus cosec. Cosec quad theta. Then d theta over dx, we know that one previously. Here d theta over dx, dx over d theta minus sin theta. Then d theta over dx means stress bracket. 1 over minus sin theta. 1 over minus sin theta. Okay. Then d theta over dx you put 1 over minus sin theta. Then minus minus plus with this minus cosec cube. That's how we differentiate. Huh? This is very special. Here this point very special, otherwise you will miss this. First you have to differentiate by theta and then multiply by d theta by dx. Okay, do it second derivative. Okay, then next derivative, third derivative, d squared by dx square we know minus cosec cube theta. No? Then when you differentiate in with respect to x again, d cube by dx cube, you have to differentiate further. D minus cosec cube theta divided by d theta. Here dx, okay. Then take minus outside. cube theta, you write here d theta over dx. Apply chain rule here. That's the specialty. Apply chain rule. Then here you differentiate with respect to theta, then multiply by d theta by dx. Okay. Continue. Cosec cube, 3 cosec square theta, cosec derivative minus cosec into cot. Then d theta over dx, it is minus sin theta in denominator. Then you can simplify now. Then simplify it. Complete. Okay. Now you see these notations. Complete that one. Okay, now see these notations. So here d constant divided by dx, we say 1. D minus fx, d constant time, sorry, here 0. Dx, here you can take constant outside. Same rules that what we have discussed previously. We can take outside constant. Then dfx plus gx over dx. You can split here. dfx dx dgx dx. Okay. Likewise, you can apply. So then d fx times gx, then here product fx times d gx over dx, gx times d fx over dx, product rule. d fx over gx over dx. We have differentiate fx over gx by x. Then gx squared, gx times derivative of numerator d fx over dx minus fx into d gx over dx. Here quotient rule, product rule, sum rule, constant scalar multiple rule. Okay, same rules I have written different form. Y equal fx plus gx. Then dy by dx we wrote f dash x plus g dash x. No? Then likewise you can apply these type of notations as well. Okay, better note it. Okay, now we have completed fundamental differentiation techniques. So we know first principle theorem on differentiation, then derivatives of special functions, then composite function derivatives, addition, subtraction, multiplication, division, constant time function, and so on. And function of function type derivative using chain rule. And thereafter we discussed, we have done specially parametric functions, exponential functions, parametric functions and exponential functions derivatives. And finally, parametric functions, higher order derivatives, repeated applications of differentiation. And higher order derivatives, first derivative, second derivative, third derivative, and so on. Then combination with higher order derivatives, we say they are differential equations. But in our A level, we don't have differential equation deduction type question, but we have to practice it. Okay? Then let's have a small interval and we can discuss further.